Hello everyone, welcome to my channel. Today we will learn about another name reaction which is Claisen condensation. I have already done with my first name reaction which is Grignard reaction. If you have missed that video, you can watch it by clicking on the link. I will put that link on my description box so that you can understand what is mean by Grignard reaction. So before starting with today's topic, I want to request you all to please subscribe my channel and click the bell icon so that you will be that you can get a notification of my upcoming videos. So let's start with today's topic, which is Claisen condensation. So what is mean by Claisen condensation? The Claisen condensation reaction is an organic coupling reaction. Here you can see that it is again an organic reaction, but it is organic coupling reaction. Coupling means what? There is a formation of a bond between two molecules. Between two molecules, you can take any molecule, but in Claisen condensation, here is the specification of a molecules. So let's move on. That results in the formation of carbon-carbon bond. Here you can see that a formation of a carbon means there is a formation of a coupling between two esters. Here you can see that it is mentioning that you have to take esters only, or one ester and one carbonyl compound. Okay, two esters or one ester and one carbonyl compound. Here is another statement or another definition of Claisen condensation. You will understand it better. When two molecules of an ester containing alpha hydrogen atoms. So let's understand what is mean by alpha hydrogen. I will take an example of acetone, which comes in ketone family. Here you can see that there is a presence of a carbonyl and two methyl group. So which carbon is called as alpha carbon? So the carbon which is next to carbonyl carbon, is called as alpha carbon. So here you can see that there is a presence of two alpha carbon. So alpha carbon, we know that which is alpha carbon, but now we will get to know that which is alpha hydrogen. So the alpha carbon which is directly attached to a hydrogen, so that hydrogen will be named as alpha hydrogen. Here you can see that there is the presence of 6 alpha hydrogen. Here is 3 and here is 3. So there is a total of 6 alpha hydrogens comes in acetone family, acetone group. Alpha hydrogen atoms condense in presence of a strong base. You have to take a strong base like sodium ethoxide. So sodium ethoxide having a formula NaOC2H5 to form a beta keto ester. What we will get is beta keto ester. So if you want to know which carbon is called as beta carbon, so the carbon which is next to alpha, is called as beta keto ester. Means in the position of a beta the carbon, there is a presence of ketone, means carbonyl group, and then ester, there will be presence of ketone and ester functional group. The reaction is known as Claisen condensation. Just remember that what will you get, that is beta keto ester. So let's understand it better by taking an example. I have taken an example of ethyl acetate. This is ethyl and this is called as acetate. Here is a two molecules of ethyl acetate. Acetate means it comes in ester family. What we have taken is strong base which is sodium ethoxide. What we will get is beta keto ester. Here you can see that this is our carbonyl carbon of a ester. The carbon which is next to carbonyl carbon is our alpha carbon, and the next carbon which is next to alpha carbon is our beta. So here in the position of a beta there is a presence of a carbonyl, and then there is a presence of this methyl. So here you can see that it is a ketone and this is our ester. So beta keto ester plus what we will get is ethanol. What we will get is ethanol. The second example of Claisen condensation, where there are two different molecules of ester. First is methyl propanoid and second is ethyl ethanoid. You can also say that ethyl acetate. This two molecules, by addition of these two molecules and a strong base, we'll get ethyl 3-oxopentanoate. This is IUPAC name, ethyl 3-oxopentanoate, and what we will get is methanol. If you take two different molecules of ester, you will get two different products. There will be possibility of getting two different products. First is this ethyl 3-oxopentanoate, and second one is this 2-methyl 3-oxobutanoate. There is a possibility of getting two products. If you take similar molecules of ester family, then you will get only one product. And if you take different molecules of ester, then you will get two different products. Possibility of getting two different products. This will be more understandable by taking a mechanism of this Claisen condensation. So let's go. Here you will understand it better. I have taken here mechanism of the first example. We have taken two molecules of ethyl acetate, which is same molecules of ester. In mechanism, what you have to take is starting with the one molecule of ethyl acetate, and then you have to add a strong base, which is our sodium ethoxide. What base will abstract a proton from alpha carbon. So this is our alpha carbon, and this proton will get abstracted by a base, strong base. This proton will become alpha hydrogen. Why? Because this is directly attached to this alpha carbon. What we will get is carbanion. Why? Because there will be shifting of this bond towards carbon, and carbon will carry a negative charge. So carbon will carry a negative charge is called as carbanion. You have to take another ethyl acetate molecule. This carbanion, which carries a negative charge, will become a nucleophile, and there will be an attack of this negative charge on carbonyl carbon, and this double bond will shift on oxygen. So oxygen will carry a negative charge. Here you can see that oxygen carries a negative charge. So after getting our double bond, shifting of this negative charge of oxygen, and there will be a formation of double bond. So after that, there is a removal of this OC2H5 group, So we will get this CH3 C double bond O, CH2 C double bond O, OC2 H5. This is our ethyl 3-oxo-butanoate. Numbering starts from this carbon 1 2 3 4. So this is our ethyl. This is 3-oxo 1 2 3 4 butanoate. Why? Because you can see that this is our ester, hence at the end ATE will be added. And what we have get is C2H5OH. This is our ethanol. This is the first example, mechanism of the first example. Hope you have understood it better. Thank you.